All right, lesson 3-1, unit 3, lesson 1. Today, we're going to look at what's called periodic phenomena, which just means something that happens with a period. The two learning goals that we're going to see today is that you're going to be able to construct graphs of periodic relationships, and you will also be able to describe key characteristics of those periodic functions. Let's begin with the definition here of periodic. Up here, I'm going to give you a verbal definition. This is a verbal definition, this first sentence. Over here, this is the mathematical definition. So verbally, when I say something is periodic, what do I mean? I'm talking about a function that's going to repeat its y values on regular x intervals. Okay, so think graphically here. What it means is that for regular x intervals, that means for the same amount of x's, the same distance between x's, you're going to have y values that repeat. And so what will they look like? They will look like waves, typically. It'll be a graph that goes like this. And it just keeps on repeating and repeating. Now, they can go negative, just so you know, but I just drew mine positive. That right there is very similar to sine. You're going to learn about next class, the sine curve. Okay, so that is periodic. What makes it periodic is the values are repeating. You see how they repeated there? And you could just keep drawing that wave going on and on and on. If you look at the back of my classroom, I have some on the walls back there, and we'll see some starting next class. Well, actually, you'll see pictures today, but we'll start seeing it in the calculator next class. Now, here's, I guess, real-world examples. Your breathing is periodic. What that means is you repeat how you breathe. For example, what's not normal, what would be irregular breathing, is if you went so, like that would be irregular. Usually our breathing is like a pattern. You breathe in, you breathe out. You breathe in, you breathe out. Your heartbeat, same thing. There's a pattern to it. Waves in the ocean, again, typically there's a pattern to it. Only in storms do you start seeing it where doesn't seem like a regular pattern. Okay, there's a couple more there for you if you want to look at. Now, here's the mathematical definition. Now look at this equation. It looks like there's a whole lot going on. This says a function is periodic if and only if there's a natural number n and real number k for which this occurs. Now, what is this talking about? A natural number is the counting number, like 1, 2, 3, 4, 5, 6. So if you took 1 times k or 2 times k, 3 times k, and k is any real number, that you end up with the same y value as just f of x, then it's periodic. And if you find k is the smallest such number, you found its period. If it's not its smallest such number, then it's actually not its period. It might be 2 times its period or 3 times. Right now, that seems complex. We're going to explain what that means later. There's the math definition, though. So, like I said, starting next class, you're going to see sine, cosine, and tangent. They are the most famous of our math periodic functions. So mathematical functions. That's what the most famous ones are. There are 3 others, but these are the 3 that are most famous. Okay, with all that, let's start. So here, your verbal definitions, let's add to the graph. And so you can actually label here. The first thing is periodic. Is this periodic? Does it seem like it's repeating? Does it seem like it's following a pattern? This is periodic. It's repeating itself. Now, how do I know it's periodic? Because I could label one cycle. For example, I could say from its maximum to its maximum. This would be one cycle. I want you to label this on your paper. So from this point to this point is one cycle. It's a complete pattern of the y values. It's from its maximum all the way back to its maximum. Now, the length itself, that is one cycle. The distance between this point and this point would be called the period. This distance from here to here, this distance is called a period. That distance equals the period. So for this graph, we're going to go ahead and write it down. This period would equal how much distance, how much of an x interval passes to go from this maximum to this maximum. Where does this look like it is approximately? Negative 4.75. And where does this one look like it's approximately? 1.5. If you add them up, you'd get the distance. Now, I actually know what this is because I know the graph is sine. And I want to show you, you can actually find the period at any different place. I'm going to go from here to here. I'm going to go from where it goes through the x-axis on its increase to the next time it goes through the x-axis on its increase. It's right there. That number is 2 pi. So this one here, the period is 2 pi. I'm going to put 2 pi. You might be going, how is it 2 pi? Well, 2 pi is approximately 6.28. Now, if you just took the numbers that I heard y'all say a second ago, approximately negative 4.75, and that is approximately 1.5. If you would add those up, you'll see that that number is really similar. Let me just clear this out. You're going to see it's really close to 6.28. We said it was 4.75 units to the left, all the way to 1.5 units to the right. When I add those together, what number did I just get? Y'all's estimate was really accurate. Here's what it exactly is, 6.28. So notice that that is really accurate of a guess. So the period goes, it's the distance of one cycle, if that makes sense. Okay, what's the amplitude? Well, it's the highest point, the distance between the highest point to the bottom point divided by 2. So this has a maximum, what? How much? What's its maximum y value? What's its minimum? How far apart are those 2 points?
3.
Not 3. They're 2 units apart. What you do is you take your distance between the maximum and the minimum. What's the distance between the max and min? Yeah, let's write this down. Distance between max and min, and you divide that by 2. You cut it in half. So these are 2 units apart. And so what's 2 divided by 2? 2 divided by 2 is 1. The amplitude on this graph is 1. You could also count from what we call the midline. That's the last one. This is the midline right here. Let me get a good color. This would be called the midline. It's the middle of the graph. That's what we call the midline. You could find the midline by the amplitude, excuse me, from going from the midline to either the maximum or the midline to the minimum. Because it's distance, it'll always be positive. You could count the amplitude that way. So I could say, or distance between midline and I'll just do the maximum because I'm running out of space. So if we want to put that on there, you can go like that. So we'll say this is the amplitude there. From the midline to the maximum is how you can calculate the amplitude as well. Okay, so there's a whole bunch of vocabulary to get us started off on these type of functions we're going to see. Any question on that? All right, I'm going to jump right in. Today we are going to focus mostly on the idea of a period, and if something is periodic, we're going to determine what the period is. Okay, I want you to look at this first graph, part A here. It says first, determine whether the function is periodic. Do you think this is periodic? Yes or no? Why is it periodic again? It's repeating it, and it's repeating the exact y values. It's not just it's a pattern. It's repeating the exact same y values, the same maximum, the same minimum, all of that. This function is periodic. Function is periodic. That's the first thing we have to do. Fine. It says if it is periodic, label a cycle and determine the period and amplitude. Okay, so to find a cycle, I think a lot of times the easiest cycle to find is maximum to maximum or minimum to minimum. So this one I'm going to label from here, this maximum to this maximum. That right here would be called one cycle. That is one cycle. And the distance of that one cycle is its period. So what would our period equal? How far left is this maximum here? -3. So it's -3 to 1. And the way you could do this is x2 minus x1. You could just say x2 minus x1, which would equal, what's our second x? 1 minus, what's our first x? 1 minus -3. What happens when you subtract the negative? You add, what's 1 plus 3?
4.
4. That's your period right there. Now, what's the amplitude? How do we find the amplitude?
The midline.
You can use the midline, which I'm going to add in a midline. Midline to a maximum. So if I did this, that right there is an amplitude. So that right there is amplitude. What is the value there? And this time you could do y2 minus y1 if you wanted to. y2 minus y1, which is the same thing as, what's the y value here?
2.
Y value would be 2, and you subtract, what's the y value here? Don't say 1, that's the x. What's the y value? 0. 2 minus 0 is 2. So that is your amplitude. So that's by formula how you can find the amplitude in the period. Yes, good question. The question was, is it always going to be positive? Because a period represents a distance and the amplitude also represents a distance, distance is always positive. So even if you wanted to measure the amplitude from here to here, you'd still say the answer is positive 2. So it'd be 0 minus -2. And so you turn it to positive like that. Good question. All right, let's try another. What about B? Is this one periodic? What do you think?
Yes.
You're 2 students, but there's like 30 in the room. There's 28 actually. So let's get some more answers. What do y'all think? Periodic or not periodic? It actually is not. And it's because of this part right here. Let me extend this out and go up and tell me, why is that not periodic? Does it actually follow the same pattern? No. And secondly, it has arrows. What do arrows mean? Keeps on going. So is that periodic? So one, the slope is off on this side. Notice this goes down 2 over 2. This goes, the way I've drawn it, it's now going, I said down 2 over 2. I'm sorry. This goes down 3 units over 2 units. Does this go down 3 units? Yes, but does it go over 2 units? No. So the slope isn't right on that part. And then, but what does the arrows indicate? They go on forever. So honestly, these should have endpoints, which I tried to cut off the endpoints. Those should have endpoints. So this is not periodic. This function is not periodic. For that reason, we won't do the amplitude or the period because it's not periodic. Okay, what about part C? What do you think here? I would say this is not periodic for a different reason. Ignore the arrows for a second. It's still not periodic. Why is this not periodic? It's not following the same midline. You see how a midline would be a horizontal line? You see how this is always increasing? the y values aren't repeating, so this function is not periodic. Function is not periodic. And you know what? I'm looking at these arrows here. I'm gonna say this is not periodic. I'm gonna take off something for the sake of the notes. I'm gonna eliminate that. Let's ignore the arrows because we might have some more pop up. I didn't even recognize that in the off their site. We might have more to pop up. This one they're gonna call periodic. Why would they call this one periodic, even though it has the arrows? Why would they call this periodic? The same y values, it's repeating perfectly, same slope, all of that. So this function is going to be periodic. So ignore the part on the arrows, but part B is still not periodic because of the first part. That first slope right here was not following the pattern. Okay, but this function is periodic. Now, if you remember, the instructions were, if it is periodic, find a period. We're going to label a cycle, and then we're also going to find the amplitude. In my opinion, the easiest way to find a cycle is to go maximum to maximum. I think that's the easiest way to do it, maximum to maximum. Let's just say this is one cycle here. One cycle. Now, if that's one cycle, what's the length of this cycle? What would be the period? I'm hearing 4. Let's check it out mathematically. How do you do it mathematically? x2 minus x1. What's our x to the right? 2 minus x to the left? -2. What happens when you have a minus and negative? They go positive. And what's 2 plus 2? Period's 4. Great. What about amplitude? Well, is this the amplitude from here to here? No, you have to know where the midline is. Now this midline is right in here. But another way you could do it is you can, if you wanted to, go top to bottom and then divide it by 2. That's another way of doing it. So how high is this? 2. So we could say it's 2 minus, what's the minimum? -1. 2 minus -1, and then we'll divide that by 2. What happens when you subtract a negative? You add, what's 2 plus 1?
3.
So it's 3/2. 3/2, we could leave it as 3/2 or 1.5. That's the amplitude here. So I took that distance and I divided by 2. So right there, as I have it, as I have it drawn, that's 2 times the amplitude. That's 2 times the amplitude, and it's 3 units. Or you could look at it from here to there, and that would be 1 amplitude right there. That's 1 amplitude. This is 2 amplitudes. Okay, so with that, I'm going to bring you to your first DOL. Determine if these are periodic, and if it is, label a cycle and determine the period and amplitude. All right, let's go on to example 2 now. It says sound waves are produced by periodic changes in air pressure. Sketch a graph of a sound wave with a period of 3 units and an amplitude of 2 units. Okay, so with just given this information, we're going to assume the midline is the origin. I mean, not the origin, I'm sorry, the x-axis. We're going to treat the x-axis as the midline. So I'm going to go ahead and just put this line on there. We're going to treat this to be the midline. Now, they don't tell us what this wave should look like. And so I'm going to make it as simple as possible. I'm going to use what we'll learn is a cosine curve here. I'm going to start at the maximum. What should the maximum be?
Period.
How high? 2. I'm going to start at my maximum. This is going to be a cosine curve. I'm going to start there at the maximum. Now, how long should it be before I repeat and get to the maximum again? 3 units. So go over 3 and plot a point at 3, 2. Follow? Now, I'm again, just to make it as basic as possible, I'm gonna put the minimum at the middle of these 2 points. Now, if this is 0, 2, this is 3, 2. What's the very middle? Would it be 1?
Mhm.
1.5. It's gonna be 1.5, and this needs to be the minimum. How low should this graph travel? To -2. It needs to hit -2. It needs to have 2 units this way and 2 units this way from the midline. And so I'm going to connect the points along the way. Now, if this is at 1.5, where would I hit the 0? Where would I hit the x-axis? If that's at an x value of 0, this is at an x value of 1.5, where should my 0 be? Not at 1, that wouldn't be in the middle. 0.75, that's what you're looking at, 0.75. So this graph would come down like this. It'll come through, and now it's going to curve back up. And the next one would be 0.75 more, so it'll be like right here. So this graph is going to come back up like this, through there. And there's one wave. There's one cycle. Now let's sketch the graph all the way to the end. How many cycles should I be able to get in this graph? I should be able to fit in 3. What I'm going to do, just to make mine a little bit more accurate, whoops, is I want to try to just copy and paste all mine and see if it works. So you go ahead and just draw yours out. What we're going to do is I'm going to copy and paste. And so this should, here's the second cycle. And I'll do it one more time for a third cycle. Should look like that. So go ahead and get your points on. I'll just put an arrow on like that. As you finish up, I'm going to just mark this one cycle. You could label one cycle anywhere, but that would be from maximum to maximum. That's one cycle. And as you note, that cycle, it takes 3 units. That would be the period of 3. That's because one full cycle takes 3 units on the x, and the amplitude of 2. That's because this value from the maximum to the midline is 2 units. So periodic, what does periodic mean?
Between.
That's a period. A period is the distance between the cycle. That's right. But what does it mean if I ask you if it's periodic? What does that mean? Repeating. And it means literally you're repeating the same y value. So you're not angled going up or down, increasing, decreasing. You're just repeating the y values over and over again. That's what periodic means. All right, now let's look at example 3 here. It says, consider how the pedals on a bicycle rotate as the bike is being ridden. So think about if you're riding a bike, you're just turning your pedals. Now, graphically, a lot of us might think of that as being circular. It's going up and down. But if you were to plot your y values instead of on an x-axis, so think of turning up, you're pedaling your bike. You know how a bike, your pedals will look like they're moving circular? Well, that's because you're thinking in terms of an x and a y. What we're going to do a lot of times in trig is not think in terms of x and y. We're actually going to think of like y with t. What do you think t stands for? Time. As over time, your pedals go up and they go down, and they go up and they go down as time moves forward. So whereas a bike, you're thinking x's and y's, and it's going circular. What's going to happen as we do this? It's time. And that's what we're going to use here. It's going to move forward. So it's not actually going to look circular. So first, it says to complete the table. So let's look at our values. We go 18. Oh, I never finished reading. The height of the bicycle pedal varies periodically as a function of time. The maximum height is 18 inches. The minimum is 6 inches. So we have 18, 15, 12, 9, 6, 9. What comes next? 12, followed by 15, finally 18. So how long does it take to go from maximum to maximum? 2 seconds. They're not pedaling very fast at all. A pretty slow pedal, in my opinion. 2 seconds to go one whole time around. So now let's plot this. The first point, this is the t-axis. The x-axis is actually the t-axis here, is 0, 18. So go to 0, 18, plot a point. And then 0.25, 15. 0.25, 15. 0.5, 12. 0.5, 12. Let's just go ahead and start plotting all those points along the line. 0.75 and 9. 1 and 6. So that's the graph going down, and now we go up. 1.25 and 9. 1.5, 12. 1.75 and 15. And then finally 2 seconds and 18. Now this actually looks, I'm going to say linear. It's not technically linear because we changed our directions, but it looks like an absolute value graph. Do you see that? So if I continue this on, I could plot out the rest of the graph. If we continue to pedal in the same fashion, we could continue to plot those points. Just, oh, come on, what's happening here? You could predict where the pedals would be if you continue to pedal exactly the same. It's like that, and we'd have one more we could fit in there. Like that. Okay, so there's we completed the table. Let's identify the period. Oh, you already told me that. I didn't write it in. What's the period equal? I'm just gonna, the period equals 2 seconds. It took 2 seconds to go from maximum to maximum. What's the amplitude? What's the highest point here? 18 to 6. So it's, if you take your y2 and you subtract y1, let me write out my formula here, y2 minus y1. If that's max and min, then you would divide that by 2. So it's 18 minus 6 divided by 2. What's 18 minus 6? 12. Divide that by 2? 6. So it's 6 units is our amplitude, which in this case, I think it's in inches. Yes, it is. 6 inches. And I've graphed with the first 5 seconds. I went ahead and did that. You could as well. There. But this thing just does not want to go over. There we go. Trying to add that little arrow to the side. All right, questions over that? Well, this brings us to our next DOL. So I'll give you a few moments. Do DOL number 2 here. These 3 questions. DOL number 2, just verbal representations. I want you to try to solve for this. Just as a reminder, how many, this says minutes here, but you're supposed to find the answer in seconds. How many seconds are in 1 minute? Yeah. So a conversion tool you can use is like this. You can either multiply or divide. You can do 1 over 60, or you can do 60 seconds per 1 minute. If you do your chemistry here, I'll call it chemistry, where you write it out. Right now, you're doing 5 cycles. 5 cycles in 4 minutes. You can write that out to find a period is the same thing as 1 cycle. A period is equal to 1 cycle. So 5 periods, and you could do it this way. You could say 5 periods in 4 minutes. Let me just change it. 5 periods in 4 minutes. Now convert to seconds and simplify to see what it takes. I'll let you work on that now. Do a little conversion. All right, example 4. It says consider the function shown. What is the period of k? Okay, what's the easiest way to come up with the period again?
Maximums.
Maximum to maximum. What is the distance from here to here?
4.
4 units. So if those are 4 units apart, that's going to be our k. And if you're like going, wait, why are you using this letter k now? I'm using a letter k because I'm going to get to this equation that we had from earlier. If you remember on the notes, the definition of periodic is that mathematically this is true, where this mathematically is true. What we're doing right now is we're solving for k, and we just found out that k is 4 units. Now it says complete the function behavior on the grid. So what does it look like it's happening every time? What's the slope here? From the minimum to its maximum, how many units does it go up? It goes up 5 over 3. It goes up 5 over 3. Now, does it go down 5 over 3 as well? Now, what happens when we go down? Down 5 over 1. So it'd be right there. And then up 5 over 3. 1, 2, 3. So it'd be like this. Let's continue on. So we'd have that followed by that again. And then we do it again. Down 5 over 1. Up 5 and over 3. Should kind of run out of space. I'm just going to put it out there like that. So that's how the graph should look. And this one, we could add this line if we wanted to. It would be down 5 over 1, which means this one could actually go on the graph like that. Okay, so we've done part B. We completed the function. Now, this says show that f of x of n plus k equals f of x is valid for n equals 1, 2, 3, or any minimum value on the graph. Okay, so what does that mean? Let's try this out. Let's just say n was 1. And I'm going to choose a random x value. Okay, so to use the easiest x value, I want to use an x value of -2. What I'm going to show you is that f of -2, I just chose a random x value here. And you're about to see why I chose -2 in a moment. Plus, I'm going to say n is 1 first. Plus 1 times, what was our k? 4. What I'm going to do is show you that this is the same thing as f of -2. So what I'm doing is I'm plugging in an x, whoops, and plugging in an n. We know k is 4. I'm going to write this as 4n like this. I'm going to prove that this is always true. No matter what x we pick and whatever n we want to use, that these will always be true. So I want to plug this in and watch what happens. What is 1 times 4? 4. So now I have f of -2 plus 4. What is f of -2 plus 4? That's going to be f of 2. What I want you to do is look on the graph. And remember, the f of 2, that means the y value. Go to the graph at 2. What's our y value at 2? 3. That value is 3. Now, what's the y value at f of -2? So here's -2. What's the function at -2? 3. Are they equal to one another? Yeah, and we could choose any number on there, and you'd find out that this is work. Let's do it again. Choose any x value that's in the domain. Any x value whatsoever. What x value do you want to choose this time? Just throw out a random number. I hear 5. So if I wanted to look at f of 5, I'm going to say f of 5 plus, do y'all want to use n of 1 again? All right, 1 times k, which is 1 times 4. Well, we're going to find out that this will be equal to f of 5. So let's simplify. What is 1 times 4? So we're doing f of 5 plus 4 is going to equal f of 5. Now, what is 5 plus 4? 9. And let's go compare f of 9. What is the function value at 9? Approximately. It's a little over 1. What about at 5? See how they're a little over 1? My line didn't quite copy over perfectly, but it's a little over 1. You see how those two are the same values? That's always true. That means if you choose any point and you added 4 units, or if you wanted to change n, if n was like 2, you wouldn't just add 4, you would now add 8. You'd add 4 twice. That's what the n is. It's how many times you adding 4. That's how you could pick up points that repeat. That's all this is right here. This equation right there is showing the definition of a periodic function. Okay, go ahead. All right. Lot there. But that's what that means. You could plug in any point you wanted to. And again, the values would repeat perfectly. All right. Your turn. What I want you to do here, I want you to plot out these points where the months, what do you think month represents on this x-axis? January? 1. What about February? What about July?
6, 8, 7.
1, 2, 3, 4, 5, 6, 7. Just make sure you plot them out like that. Sketch it out. Describe what would be the period and what's the amplitude. All right. DOL number 3. All right. Example 5 here. Let's pick up some speed here. It says identify the following characteristics. The period. What's the period? I'm going to go from maximum to maximum. I think that's always the easiest. That would be 1 cycle. What's that from there to there is 1 full cycle. 1 cycle. How many units is it from -6 to +2? You do the maximum minus the minimum. 2 minus -6 becomes 8. Period is 8 units. Very good. What's the amplitude? Again, maximum minus minimum. So 3 minus a -3 is 3 minus a -3. Minus a negative becomes positive. So what's 3 plus 3? 6. Does that mean my amplitude is 6? It's 6 divided by 2, which is 3. That's the amplitude. So a cycle has a length of 1 period. There's my amplitude. It's 3 units. The maximum. What's the maximum value? 3. What's the minimum value? -3. There you go. Intervals where it's concave up. Okay, start with here. Is this concave up or concave down?
Down.
Concave down. What about this one? Okay. So here's how I'm going to do. I want to just go from this first one. Concave down. Let's say it's from 0 to 4. It would be 0 to 4. And then it repeats how often? Every, where does it start over again? -8. So it's every 8. So here's how you do this. From 0 plus 8n. Okay, that means it could be 8 times -1, 8 times 1, 8 times 2, whatever. So that would be that value. And then where does it stop being concave down? With intervals, you do parentheses, not a bracket. Where does it stop being concave down? At 4. And so it'd be 4 plus 8n. Because that's the period. Okay. Where n is an integer. Where n is an integer. That's how you'd write that. A double Z means it could be a -1. It could be a 0. It could be a +1, so on. So where is it concave up? Well, if this is concave down, this is concave up. And so it's very similar. This time it'd be 4 plus 8n. Goes from 4 to 8. And this would be 8 plus 8n. So again, the 8n, the 8 is the period. This 8 and this 8 with the n is the period. And n is any integer. No, I said natural number at the start. I should have said integer. It's an integer. And points of inflection. What does it mean to be a point of inflection? That's right, when the concavity changes. So where do we change? At 0, 4, 8. These are the points of inflection here. So what you could do here is I'm just gonna say, you know, what's 0 plus 8n? I could have reduced that. What is 0 plus 8n? What's 0 plus anything? Whatever it was. I could just leave that as 8n like that. The points of inflection would happen every 4 units. So you just say 4n, comma 0. The y value is always 0 there. Where, again, where n is any integer. The reason this is not 1 period apart is because there's 2 per period. So like that. Those are the points of inflection. Which will bring us to your next DOL. I'll allow you to do the same. All right, example 6. A storm siren makes 2.5 rotations per minute. I want to pause here. A rotation is a cycle. 1 rotation is going to be equal to 1 cycle. And a cycle is the same thing. The distance of a cycle is the period. So it's saying 2 rotations, 2.5, excuse me, 2.5 rotations, which some people will call it a revolution, per 1 minute. What you can do, whoops, if you had to convert out of this, the 2.5 revolutions, that's a full cycle or a period. Okay, so it said here rotation, that's the same thing as a revolution, all that's equal to 1 period. So if you had to change that, they're going to change it to seconds. What you would end up doing is you do 1 minute over, not equals, I'm sorry, I want to multiply times 60 seconds. And when you simplify, you can find out what 1 period is equal to, or 1 revolution. So here, minutes cancels with minutes. Let me change colors, sorry. Minutes cancels with minutes. And so 2.5 revolutions per 60 seconds is the same thing as if you divide that out. Let's just use a calculator. 60. How many times can 2.5 go into 60? 24 seconds. 24 seconds is going to be 1 period. So if 1 revolution would equal 24 seconds, then 1 period is the period equals 24 seconds. That's what we just discovered there. Okay, so anyways, continue on here. And the sound waves have a radius of 1 mile. So this is talking circular. That's why they use rotations. So the radius of 1 mile. Mr. Tyler's house is located 1 mile south of the siren. The distance the sound waves from his house varies periodically as a function of time. What is the period of the function? Oh, we just got that. It's 24 seconds. Okay, that's what I did all up there. So I'll put here 24 seconds. 1 cycle or 1 period. Oops, forgot the I. There you go. Period equals 24 seconds. Now let the x-axis represent time in seconds from 0 to 60 seconds. That means 1 minute. So we should have 2.5 cycles in here. Let the y represent the distance the sound wave is from Mr. Tyler's house at any time t. The siren begins its rotation facing north. So we're 1 mile south. So the siren starts 1 mile. So if here's the location of the house, let's just say distance-wise, we're 1 mile south of the siren. So we're here. Well, that siren actually, it says here, the siren begins its rotation facing north. And it has a radius of 1 mile. So it actually starts here at 2. So this would be like the center location. This is south. So north, south, if you will. Here's the center. The center is here. So we start 1 mile to the north. And then it takes 24 seconds to go all the way back to here, which means the minimum would be at 12. And so this would actually go through. I want to round off the edges rather than making them linear, because that's how it's technically going to work in the real world. And so, and then you would repeat that. And so there's one cycle. I would have another cycle that would take another 24 seconds. And then I'd have half a cycle by the time we hit 60. So by the time we hit 60, we've had 2.5 cycles. So I think I have that graphed accurately. Again, the midline is here, and notice that it says its radius is 1 mile. And go 1 mile this way and go 1 mile that way. And we are located 1 mile south. So this would be the distance. This is the distance from the siren to Mr. Tyler's house. So it comes and here, its distance, it would be right there at 12 seconds. The siren would be at Mr. Tyler's house. So this line right there, that represents the midline. Let me add that in there. Since we haven't done that in the last few examples, that's the midline. Okay, now with that, I'll give you your last one. Here's your last DOL. You go ahead and fill out all this information on the Ferris wheel. Remember, a revolution is the same thing as a rotation, which is the same thing as a cycle.